Good morning to all of you and welcome back. Today, just to recollect, like 75% of the internet traffic what is delivered in an entire day is served through Citrix Netscaler. The primary reason is we ensure the performance of the websites are always up to the date. In today's session, I would be focusing more on the optimization technique which are corely related to the performance. As we all know, the servers are getting consolidated in the data center, and on the other ends, users are moving far away from the data center, and the expectation is pretty high. We need to ensure the application which is delivered to the end user has always performance up to the mark. That is what the business agility is all about. We will ensure whatever the application that has been delivered to the end user is in the acceptable format. Users come through a different network, they come from a different carriers. It could be Wi-Fi, 3G, 2G. Still we need to ensure, irrespective of the link the user is following, the performance is up to the mark. There are key features what have been categorized as the part of the performance, something known as TCP multiplexing and buffering, app compression, app cache. FEO is the new feature what we have come like almost a quarter end now, and the SSL offload. We would be doing a deep dive technical session into each of these features, how this feature will ensure like performance of this server is up to the mark. So far, like we have seen in the industry, the focus was more on the server side processing. With the introduction of FEO, we are changing evolution, we are concentrating more on the client side processing. How do we ensure the client processing which required like heavy images to get downloaded from the data center, the amount of time it takes will get reduced. TCP buffering, like many times we seen, like server is responding a 2 MB of file or 5 MB of file, but the data or the network on which it is following is pretty congested. And because of there are multiple round trip time delays and all that, which is causing the user performance to get impacted. Buffering is the key feature what we try to make it here. Like whatever the response come from the server, we try to store it on the Netscaler itself and give in a chunk response to the end user. This is a classic flow of what the TCP offloading is all about. TCP as the nature of the protocol always trying to do a three-way handshaking before it can get any data from the server. So here, since Netscaler is acting as a server between the client and the web server, the flow is something like that. Netscaler acts as a server to the client, and it acts as a client to the web server. What I meant by TCP offloading, the three-way handshaking what is normally done at the layer 3, that is done between the client and the Netscaler. Okay. Once the handshaking is done, the actual data comes. In the actual data, Netscaler what it does, it will take the connection from the ideal sink, what we call as a reuse pool, okay, and on the same established connection, okay, it will try to fetch the data what the client has requested, okay. Okay. Once the data has been done, the closing of connection, if you observe, it is only between the Netscaler and the client. So this connection what is already here, it is always there in the pool. So this helps you to store the amount of CPU and the memory cycle is required to build up that connection will drastically reduced. So same server which can hold up to 10,000 connection, because of reuse ability, now it is able to hold more number of connections.
What about the latency we can use?
That is, so this is like same thing. So today in the world, like if the client is talking to server directly, correct, whatever the latency is there. Now here Netscaler is acting as a server on behalf of the web server. So here what is happening, Netscaler is acting as a reverse proxy, okay, where it accepts all the requests on behalf of the server.
So it is caching also?
Yeah, I will talk more in detail on that. And once this TCP connection comes out, it straight away starts the fetching of the data. So this is a classic example of what TCP multiplexing is all about and how the reverse proxying solution works. A client will initiate a three-way handshaking with the Netscaler. Okay, his session get terminated on the Netscaler. In the second request, this is the actual flow where the data comes. Okay. Now in this here, if you can observe, Netscaler is building up a TCP connection between the Netscaler and the web servers. Once this connection is built up, okay, Netscaler will start requesting for the data what client has requested. So this is the normal flow what we have today in a TCP cycle. Now what I mean by connection reuse or TCP multiplexing, the true meaning is here. Okay, when we have a multiple connections from a different client, we are not building a connection between the web server and the Netscaler. We are making a reuse of the TCP connection, which means the 4 connection which required to be built up a server, instead of that there is only single connections, which helps you to free some CPU and the memory, so server can process more amount of traffic. And here also the server is also ready to take the data because the TCP cycle is already built up there. Okay. The second key thing, once we do this activity, the server which was initially working at 70-80% of the load, the CPU drastically comes down to say 10-20%. So now the same server which is causing the load at the infrastructure, there is no need to improve any server hardware at that end, since the Netscaler is Dell which does this take part for you. When it comes to compression, Netscaler today supports HTTP 1.1, a standard RFC compression basically used for the web servers. Okay, when we normally see a 5:1 or a 6:1 compression ratio observed for JavaScript, content style sheet, PDF documents. Okay, so this will help you to reduce the bandwidth which is core required between the client and the Netscaler. Okay, as well as the end user performance get improved because the number of RTT to transfer the same amount of data get reduced. So if the data is less than 54 KB of byte, we can transfer the data into a single chunk, and if they are more than that, we will transfer it into a chunk of data. Let's have a pictorial view of the same. So a client is requesting a data. Sorry, I think this is not seen here. I am able to see on the screen. So there is a gray color toolbar which is going from here. This is not seen when it is coming. Okay, just I want to highlight, see what is happening. The client here is requesting some data which is coming from the server. Once all this data has been requested or it is coming from the server, the Netscaler at this end will do a compression and send the data at a one go to the client. So this is what is happening. So now this compression is a CPU intensive job. So basically what happens, if the server start doing a compression on behalf, okay, it will consume lot of CPU and memory. Once this job has been offloaded, okay, the same server is able to handle more number of users, as well as the compression job what is doing is offloaded to the Netscaler itself. When it comes to caching, okay, we are capable of caching the static cache as well as the dynamic cache. One of the good part is we do the caching of data in the RAM. So today we allow 50% of the physical memory can be allocated for the cache. What I mean by that is, suppose we have an appliance which is of 8 GB, you can allocate up to 4 GB for the cache, and this cache is in the RAM. So what happens, when a subsequent request or a request coming for getting the same content delivered, we will not go into the web server itself, rather than we can deliver the content from the cache itself. So let's have a pictorial view of that. So first time a user comes, okay, he is trying to request some content, okay, the Netscaler cache is empty. Here what happened, we go to the backend server, we get the cache. Once the cache has been delivered, we built up a cache history on the box itself. Subsequent request coming from second, third and fourth user for the same cache content, okay, we are not going to the backend server, we are giving it from the cache itself. This will help you to save some CPU and memory cycles, because the repetitive data what is required by the client has been delivered from the cache itself. A classic example is of a newspaper agency, like we all go to a website to go through the news, correct, in every morning. So now if the repetitive content that is getting stored on the server, okay, the server is busy giving the same data. So instead of that, we try to offload that data and put on the box itself. So the same server which used to be at 60%, 70% in the peak load time has been drastically come down to 30%. This is what the key benefit we achieve using this thing. A second key thing what I want to highlight when it comes to the I think there is some issue with this. The second thing what I want to highlight you is with the dynamic caching. So okay, normally we as an Indian are a big fans of cricket. So whenever there is a cricket, either a one day or test match, what happens, we keep refreshing the scorecard, correct, to get the data what is the latest update. Now with this approach, okay, if there is a no caching mechanism there at the Netscaler, what happens every time we'll go to the server and try to fetch the data. Now once this offloading is done, whenever you do a refresh, okay, the repetitive contents can be given from the cache itself, what is called as a dynamic, because it goes on changing as and when. But we ensure the data what is delivered from the Netscaler is always up to the mark with the help of server using a parameter called as PET. There is something known as polling time interval, which ensures the data what has been delivered from the cache of the Netscaler is always up to the date with the origin of the content. What I mean by is data are always in sync, whatever is there in the cache, the same data is there with the server itself. Okay. This is the new thing what we have came up with recently, okay, Netscaler mobile stream. Here we are doing more with the optimization. So far the focus of the industry was to optimize the load at the infrastructure end. What I mean to say, like using the compression and caching technique, what we are trying to achieve is reducing or offloading the load of the server. Now with this new functionality, okay, we see like users coming with a variety of devices. These devices are from different firmwares, they are with different OS, okay, they are with different screen size, they are with different network carriers what they come, okay. Now the focus of the industry has been changed, where we need to look of something how efficient we can ensure the content of the web get delivered. Sorry. So with this approach, okay, Netscaler is trying to do a front-end optimization which has more to do with the client-end processing. What I mean to say client-end processing, like when a website get delivered at the mobile, okay, it has got some embedded image. Now this embedded image are itself into an object which get delivered or which need to be downloaded on the client hand side. And it's a pretty time-consuming job because it's an image which takes a lot of time to deliver and all that. So with this approach, what we try to do is, these are the key optimization technique what we try to highlight. Okay, domain sharding, image GIF to PNG, external scripts, moving CSS. Applying this technology doesn't need any change at the application. So good part is we do all this on the fly without making any change at the backend application. A classic example of this is this. Domain sharding. As we all know, browser by default restrict number of multiple TCP connection. What I mean by is, the browser will allow only 2-3 TCP connections and try to fetch the data. Now the sites on the other end are becoming heavier. A normal website is of 25 objects, and in case of e-commerce this has moved to 200 objects. Now we can imagine if 200 objects needs to be fetched on a 2 TCP connection, the amount of time it will take. Now with this technology or with this terminology of domain sharding, Netscaler will intelligently force the browser to allow open more number of TCP connection. Once the more number of TCP connection opens, it can fetch more number of objects. This will help you to reduce the amount of time it takes to open the page on a particular browser. This is a pictorial view of it. A client is requesting an abc.com. Okay, Netscaler will go to the backend, try to fetch the content. Once it is getting a content, okay, with the help of domain sharding, the client is able to fetch the multiple data for the same site. Because it has allowed me multiple TCP connection. No, so this is the first time when there is nothing in the cache. Okay, here we are talking about something known as domain sharding. What it means, Netscaler will intelligently force the browser at the client end to open more number of TCP connection. And once the more number of TCP connection has been opened, it can fetch more number of data at the same time. So today a browser is limiting us to open few multiple TCP connection. That is the default nature of the browser. So if you are trying to fetch a website which has got 200s of objects with few TCP connection, it will take more amount of time. Now with this approach, since we are able to open multiple connection, we can fetch more data in a lesser amount of time. This will ultimately improve the end user performance when you try to access a particular portal.
Any need for changing the mobile settings for that?
No, nothing. That's what. Okay, when we enable this functionality on the box, nothing to be done at the back-end application. Okay, the box will intelligently do the magic of ensuring the performance which has been delivered on this mobile device has been improved. Second key thing what I want to highlight here is the client-side caching. What I mean by this, many a times what happens, the client is there who is accessing some data of a particular portal, say abc.com, okay, and the abc.com has many static images. So every time in the morning he comes, all this object will get delivered either from the Netscaler or from the server. Now with the help of this option, okay, Netscaler can on the fly change the age limit of the cache object and deliver it to the mobile phone. What I mean by this, if the same content client is requesting every day, we can force this content to get cached on the mobile device itself for 2 days, 3 days. So what will happen if a client is again requesting for the same data, we will give it from the local cache.
So this is applicable to the laptops also?
Yeah. So we will forcefully get the content cached in the laptop itself, unless and until there is some browser setting which configures to clear the cache. If that is not there, whenever a client try to get the same data, we will get it from the cache itself. So we try to on the fly change the age limit of the object what server has set. So normally server is configured with 30 seconds, 40 seconds, maximum 1 day. We can on the fly change that setting to 2 days, 3 days, and it's a configurable parameter for you.
That will be dynamic.
Yeah.
So do you mean that, I mean, you will force the browser to keep that information?
Yes. Yeah. So unless and until the browser is configured with like clear cache on exit, we can't do anything. So which is not the setting by default. So what I'm trying to highlight here, you can force the content to get cached on the client browser for a longer duration. So let's have a pictorial view for it. Okay, first time when a content has been requested, there is no content in the cache of the Netscaler. Netscaler on behalf of the client will make a request to the server itself. Okay, once the server responds to it, okay, the same content has been delivered to this. Here what happens, intelligently Netscaler will build up the cache of its own. So next time if client is requesting something or a second client requesting the same data, we will not go to the server, we will do it from the cache. But the beauty what we add here is, we can force the cache getting on the client device for a longer duration. So what happens if the content is there in the cache, you can see here the configurable parameter what I had configured here was for 3 days. So if the client is requesting for a content which is there on the cache, Netscaler will push this content to get stored on the client device for 3 days.
That will be for that particular client? Or
Yeah, that is for that particular client. So as and when the client comes, this policy will get applied. Okay. Second thing, as we all know, like GIF is pretty heavy image. So if your website is hosting lot of images, the client who is accessing it, it takes a lot of time to download that thing. Now with this approach, what happened? Netscaler will on the fly convert a GIF to PNG. This will give you 2 benefits. One, the client, the impression of the site which is getting loaded get improved because PNG comes faster as compared to GIF. And the second thing, the amount of bandwidth we need to transfer the GIF from the data center to the client is more as compared to PNG. And this is like nothing to do with the application, everything to do on the box. Second key thing what I want to highlight is like JSS inline or JSS minify. JSS minify, like application owner, what he does, he always try to write a fancy code for us, correct, and he puts some comments into it, correct. I had a pictorial view of that also. So what happens, he writes a code and he writes some references for his information, okay, why he has written the code as a bookmark to it. Now without gaining the knowledge, okay, this bookmark is ultimately adding to the bandwidth which is going towards the client side. Suppose I have a 10 KB of page, but there is a 5 KB of information, okay, which the developer has written for his information. This is adding to the bandwidth of 15 KB in total, correct. Now with this approach, what we try to do, the box will intelligently identify is there any developer code inside the HTML code. If yes, it will remove it on the fly. So the 10 KB of the data will go as it is. So 10 KB is just a minimal. Today you access any website is more than 150, 160 KB. So if I try to remove the content of the developer comments which is of 30, 40 KB, you can drastically reduce the bandwidth, and on the other hand we can improve the amount of time which a page takes to load at the client end. So I had not gone through each of them. Feel like this is a classic example, CSS moves to ahead. Like what it meant by it, a page may have a JavaScript, it may have a content style sheet, correct. This is the normal how the web page is developed. Now JavaScript, we all know it has more to do with the submit button, correct. But if it's there at the top of the page, the content style sheet which is at the bottom of the page take a lot of time to load. Now with this approach, we can move the content style sheet at the top, take the JavaScript down. This will help you to improve the page which get rendered at the client. So he get a faster response. because the submit button what need to be appeared will slowly come down, but the meaningful information what is looking at it get delivered with the help of CSS. And this is applicable to HTML as well. Okay. We have also got one of a unique thing, I don't have a pictorial view of that, like if there are space between the codes, okay, we can remove it on the fly. This will help you to again save up the bandwidth and improve the end user performance. So with this I have done like I think we need to cover this time. Yeah. So one of the unique thing what we have developed specifically for Apple phones, okay, it is currently there only with Apple phones, okay, Samsung and Androids are coming on the roadmap. MPTCP, the full form stand, it's an multiple TCP path which exists between a mobile phone and the application. So Netscaler at the other end, okay, will intelligently identify whether a user is coming from an Apple phone, whether it's a to connectivity to the Wi-Fi as well as to the carrier wherever it connects, okay, and with this approach, okay, it can intelligently identify where there is a congestion in the link, if this link or this link, okay, and based on that, whatever the heavy content that need to be delivered on the mobile phone comes through the uncongested link, and the smaller content can deliver through the other link. So what the key benefit what I am trying to highlight here is, okay, going ahead, we may have an Android phone which can talk to a multiple internet connectivity at the same time, and on the other end Netscaler can distribute the load of the amount of information what the user has requested from the web servers. Yeah, because Netscaler sitting at here, it's able to intelligently identify the two links, okay, where the congestion is all about. If the congestion is not there, it will try to push more data here, okay, and it will try to push the less data on the congested link. So currently this is available with specific iOS from Apple, okay, like Android is in the roadmap to get this functionality.
It can be irrespective of the antenna, right?
Yeah, it can be irrespective. Here the main focus area is that we need to have multiple internet connectivities what the mobile has in with it. Yeah. As we all know, like 1024 has been detected as a vulnerability. There are regulations and rules already in the place. People are forced to move towards 2048. So Netscaler as a technology is ready with 2048. Okay, it has gotten KVM chips inside and specialized hardware which are meant for encryption and decryption. So what happened, like once you do the offloading, I mean the offloading is between the Netscaler and the end computer where a 3 encryption and decryption of the tunnel get established. Okay, instead of doing at the server, okay, we do at the Netscaler. This will help you to improve the performance of building up this tunnel with 30x. And this is the core feature what we have. That's the reason, like whenever we see a payment gateway website, okay, you find more of a Netscalers there. Because the offloading and I mean to say encryption and decryption happens at much quicker rate as compared to when it is there on the server or at the competitor box.
Right, so just to add on to the SSL offload functionality, this is one of the critical thing everybody knows, HTTP migration, HTTPS, like, securing the link for any, external portal. So this is one of the key thing which we have seen in the market where earlier people used to have the 1024, the SSL offload happening on the devices, the load balancing devices which they had. But when you are migrating from 1024 to 2048, the amount of SSL hits per second which that box or the appliance which can able to handle is drastically come down. So what you ended up in buying additional more boxes just to have the number of HTTP per second number of people supported. Like, that's where Netscaler plays a completely it's a clear differentiator where compared to any other vendors in the industry, Netscaler provides more than double the amount of 2048 2K certificate SSL hits per second, right? So you can compare with any other vendors. That's where you will see a huge reduction in terms of your investments on SSL offload from devices or the functionalities which you invest. So that's one of the critical thing. We also talked about the other functionalities. Karthik talked about the performance, the compression, caching, and as we mentioned earlier, for any of these performance, one of the most critical thing is the memory. You need to have a lot of memory, wherein this guy is going to help reducing the server workload and help improving the performance of your application delivery. And that's where all the Netscalers been designed from the lowest model to the whatever the topmost model which we have. Like it comes with highest memory. Like you can compare apple to apple in terms of the throughput with the memory with any of the other vendors. You will find Netscaler has a good amount of memory, because when you enable the multiple functionalities, it should not disrupt the other functionalities. Based on that context, we have put in a lot of memory over there, and that will help you improve the performance of the application delivery. So before we move on, any questions from anyone? Sorry?
So currently, no. So currently we are with RAM. Okay, in the later release, whatever the new appliances coming, we are expected to have SSD in place. So the cache today, what we have, like 50% of the physical memory can be extended beyond that.
You talked about the user session being contained in the appliance, unless session is going to the web server.
Yeah, TCP.
How do you maintain the user sessions continuity? I mean, the sessions had to be maintained at the web server normally.
Yeah.
So if you do that in the
So in normal year, the expectation is Netscaler is deployed in a reverse proxy. So what I mean by this, the client will think Netscaler as a server. Netscaler act as a client to the server. Okay, so what is happening, the TCP connection which get initially built up between the Netscaler and the server is always open. So once the client does a three-way handshaking, we will take this connection from the reuse pool, okay, and just fetch the data what the client has requested and give it to him. So this will drastically reduce the CPU and the memory cycles what is required to build up the initial TCP connection for 1000 to 2000 clients. And addition of deletion, the connection between the Netscaler and the servers can be done on the fly, and it's not a configurable parameter for
you. Any other questions? Yeah. Can pass on the mic over there.
I have one question about the compression. Basically, in a scenario where say Windows 2012 server is being used and it's a VDI environment, so I have seen that in certain cases the bandwidth utilization is up, then it's the higher side, more than 100 kbps per user or so. So how Netscaler can help reduce bandwidth consumption here?
For HTTP app, right? So just remember that Netscaler is anything and everything to do with HTTP. If there is a HTTP traffic, right, which is consuming a lot of bandwidth over there, the compression, the way at which Karthik explained about the way a compression works, right, it squeezes down the packets and it ensures that the packets are resized or probably minimized to the extent possible, and it's sent across. That's where the user feel that performance improvement of the application delivery. Right. So again, it's for HTTP traffic.
you. Yeah. Okay. So if it is, sorry.
Yeah, my question was specific to a VDI environment where that Windows 2012 desktop, virtualized desktop have been implemented. So, and how that network traffic compression can happen in this scenario as the traffic is being passed through.
So it's a virtual desktop delivery which you are looking at, like, okay. So we are going to cover that. That's a part of Cloud Bridge, which is a WAN optimization piece. Okay. Because the virtual desktop is not a HTTP traffic, and hence, Netscaler cannot do the compression part of it over there. So that's a clear WAN optimization piece, and we can talk about how Cloud Bridge helps in terms of squeezing down the HDX, which is a ICA protocol, in the later session.
Okay.
We're going to cover that. Yeah. So one of the key thing, when it comes to he talked about the TCP, offload functionality, and when I have seen a lot of customers whenever we have this discussion with the customers. So we have seen a majority of the application which is being used by a lot of enterprise corporate customers are web apps today. It may be a very small, application. It can be a travel application for the internal employees, or even the biometric, the backend, application may be a web application, right? But they might be hosting it on only one server. So the question always comes from the customer is how can load balancer can able to help me when I have only one server? It's a very logical question. It's a very intelligent question again, right? That's where TCP offload plays a major role. When you actually look at the TCP connection, whatever the HTTP connections, it takes around a lot of power or the resource from the server. So when you have a Netscaler, even if you have one single application running on one single server, Netscaler helps reducing the server workload by 50-60% and improve the performance of the application delivery drastically. That's where you will see a difference even for an application running on a single server, enabling the TCP offload functionality over there. Right. So with that, thanks, Karthik. I think we will move on to the next